So welcome to the first workshop on NSF and DOE high-performance computing tools. It's my pleasure to introduce Dr. David Conover, our Vice President for Research and Innovation at the University of Oregon.
Thank you, Samir. Good morning.
Good morning.
Welcome to the University of Oregon, and thanks to all of you for being here at this inaugural workshop. I'm really pleased to see such a wide array of different attendees here today. It's a truly interdisciplinary event that brings together developers, scientists, senior personnel, and others from different agencies and institutions. And our office, the Office of Research and Innovation, is very proud to be supporting this workshop. Having served as the Director of the Division of Ocean Sciences at the National Science Foundation, I know that advances being made in high-performance computing are extremely important for the strategic science and engineering mission of the U.S. Because they provide simulation and analytics capabilities necessary to address our most pressing problems. I also recognize that this has been an important area for our own institution. We've made numerous investments in this realm, including major investments in high-performance computing, which we launched just a couple of years ago. We also have now launched a new initiative, a presidential initiative in data science, and we're hiring a large number of faculty in that area. And of course, our biggest initiative is the Phil and Penny Knight Campus for Accelerating Scientific Impact. If any of you came in on Franklin Boulevard, you saw a big building undergoing construction on the far side, which is from the main campus, but it's immediately adjacent to our science complex. And that new building going up is our new Campus for Accelerating Scientific Impact, which is a $1 billion investment to fast-track scientific discoveries into innovations that improve the quality of life for people in Oregon, the nation, and the world. And it's all based on a gift from Phil and Penny Knight. So if you hear people saying that this is just the University of Nike and that Nike only supports sports, that's like completely wrong, because there are huge investments in academics that come from the Knight family as well, and this is one of the best examples. Advanced computing is at the heart of much of the research, innovation, and educational directions we are pursuing. We are very proud that one of our institutes, the Oregon Advanced Computing Institute for Science and Society, which is run by Al Maloney, is a very important part of that portfolio. And also within OASIS is the Performance Research Lab that Samir runs. And these and other efforts give the University of Oregon a strong connection and importance of high-performance computing for research, development, and technology. I'm excited that the first joint workshop jointly sponsored by NSF and DOE on high-performance computing tools is taking place here on our campus. The workshop is an opportunity to tackle some of the technological issues in creating extreme-scale scientific software. The outcomes you will achieve are key to making HPC solutions more productive and accessible. I'm especially happy to see the partnering of NSF and DOE in this effort. I want to acknowledge Manish Parashar and Vipin Chowdhury for being here today. And I want to thank NSF and DOE for supporting this meeting. I also want to acknowledge Mike Haru and Jonathan Carter for their leadership in exascale computing project on HPC software. So again, welcome to the University of Oregon. I hope you have a great meeting. And now it's my pleasure to introduce Vipin Chowdhury, Program Director of the Office of Advanced Cyber Infrastructure at the National Science Foundation.
Okay, thank you. A very good morning to you all. I'm not going to use any slides. But first of all, thank you to University of Oregon for hosting this, and Samir for pulling this together so quickly. Great to see such a wide range of HPC resource providers across different parts of NSF being here. I am Program Director within the SICE Directorate, specifically the Office of Advanced Cyber Infrastructure. I lead the software group, so the CSSI program. Some of you might be familiar with this, the Cyber Infrastructure for Sustained Scientific Innovation. And you might have seen in that we have focused a lot on delivery of software. And so this really fits in very well. Now, before NSF and before some of the academic stuff, I was involved in a few industries and with HPC as well. So I know how the package, the kind of dependencies you have in HPC software packages. That's a huge problem. And I've been in 3 different industries, HPC to more of the enterprise stuff. And it is hard. And in every location, we sort of concocted our own tools to do that. And HPC is hard. Enterprise, I believe, is even harder because you have Windows in there as well. So it's my pleasure, actually. I'm really happy that we could have DOE's experience with the ECP project, where the SPAC package manager has been developed, and a lot of the other tools with the E4S, the extreme scale software, scientific software stack, right? Lots of words there. So that, hopefully, the idea here is to have NSF resource providers see if that can fit into their ecosystem. Right? Clearly, having a standard is useful. Then one can take applications which work in DOE space, can work in NSF space, and very important for NSF, the other way around too. We have PIs which span both DOE and NSF. They have funding from both, and the software moves across those. So I'm really excited that we could actually pull this off, and having standards is good, but I would also caution that standards also stifle innovation sometimes, right? So it's good to have SPAC. Maybe we need to learn to go to SPAC 2.0, 3.0, and so on to see how things are moving. But with that, welcome to everyone, and thank you.
So, good morning, everyone. Excuse me. I'd like to echo David and Vipin's welcome. I'm great to be back at this beautiful campus. It's also great for me that for a change, I have an ECP meeting, which is in the same time zone. So that's always beneficial. So I'm standing here talking about ECP, but really there's a whole lot of people who've contributed to the development of both the infrastructure and the software, and I've just listed a few of those names here. Oh, sorry, yeah. You did tell me. I just want to give you a very brief introduction about the context of these tools, where we're coming from, and overall about the DOE's exascale computing project. So I'm going to jump straight to the software technology area. It's actually a very large project, almost $2 billion over 5 years, and it has components in application development, software development, and also infrastructure to do with integration with the DOE facilities. And the software technology goal basically is to build this coherent, comprehensive software stack, which will enable the application developers to exploit exascale machines as they arrive. It's divided up into 6 focus areas based thematically on kind of content the software is meant to address. So programming models and runtimes, development tools, math libraries, data and viz, software ecosystem, which is really kind of the source of much of what we'll be talking about in the next 2 days, which is to do with packaging, deploying the software and things like that. And then another area which is to do with software technologies which are being developed by the NNSA labs, which is kind of broken out like that for more of a kind of administrative reason more than anything else. In the interest of time and everyone's mental well-being, I'm not going to list all the projects, but if you're interested, I would encourage you to go to exascaleproject.org. If you click on the Software Technologies tab, there's what we call the Technology Capability Assessment Report. The second version of that was released just quite recently. It has a list of all the projects we're funding, a brief 2-page description of what they're about, and a lot more context than I have time for to describe where we're going as a team. A little bit about this idea of delivery and deployment, because it's really critical to making ECP a success for the DOE. So we have, as I mentioned, a lot of different software projects. Some are historic. They've been being developed over many years in some cases, and ECP is just an increment to their funding, and some are completely new. But there's very many of them, and one of the ideas, one of the kind of the goals is to aggregate them first into what we call software development kits, which are based on compatible functionality, and to make them interoperable within this SDK space, and also to come out with uniform APIs as much as possible. And then we need a system where, from these building blocks of SDKs, we can roll these up into a larger software stack and make release and deployment to our HPC systems as transparent as possible. And this is where E4S and SPAC and other tools come in. And then the applications will hopefully make great use of them, and then they'll run on the exascale systems. And a quick note on this idea of SDK. So it really arose from us leveraging this slightly older idea, older than ECP, which started in the math library community. It's called Extreme Software Development Kit, XSDK, and it was really came about from people's experiences of wanting to use more than one math library and not being able to build them all in the same package. So there was kind of a classic example. I think it was Trilinos and maybe SuperLU, and they both had a header file with the same name with different definitions in. And a whole bunch of homegrown solutions emerged to this, but it would be just better if all the math libraries agreed not to have naming collisions like that. So out of that kind of unfortunate incident, the XSDK was born, and many more math libraries have been added into it over the years. And kind of the standards idea, we kind of shy away a little bit from maybe from using the standards words too often, because a lot of people armor up when they hear the word standard and prepare to fight. So in XSDK, we have community policies, which are discussed and everyone agrees to, and they can be amended. In fact, XSDK has just come up with a new list of community policies based on input from other math libraries that want to join, other math libraries external to ECP, I should say. So we think this is a very interesting and useful concept to increase the modularity and interoperability of software. And then just a word about the Extreme Scale Scientific Software Stack. So we picked a name which doesn't mention exascale because we want this software stack to include things that are not sponsored by ECP, things that are developed by other funding streams at other universities and in other countries. And we don't want it necessarily tied to ECP. We want this to live and be useful beyond exascale computing projects. And there's a lot of software already in this, already in E4S, and this may be out of date because Samir, who is leading this project, is incredibly productive with his project and adds things really all the time. And our plan is to release all the ECP software through E4S certainly by the project end, but certainly much sooner, I think. And that was all I really had to say before we get started with the tutorials. You'll hear about SPAC, you'll hear about containers tomorrow, and I think you'll hear an overview about E4S. So thank you all for coming. There'll be a session tomorrow afternoon when we can have a discussion about what other things you would like to hear about in these workshops, how we can improve the coordination between DOE and NSF, and things like that. And I really look forward to that session and the whole of the workshop. So thanks again.